Hey guys, it's me, Miss Perenboom. We are going to be looking at Learning Target 8C today and focusing on the intercepts of linear equations. Okay, so first question, of course, would be what are intercepts? Now, I don't know about you guys, but when I think of intercepts, I immediately think about football, right? And so when we think about football, we're thinking about when a quarterback of one team throws the ball and the path of the ball is intercepted by the path of a player from the other team, right? So somebody from the other team catches the ball, they cut off that path. Okay, so when we talk about intercepts with graphs, there is a little bit of similarity there in the sense that what we're looking for is where does the path of the line intercept either the y-axis or the x-axis. And so we're looking for where do the path of those lines meet, okay? And so if we're talking about the x-intercept, then we're looking for where does the line, so for the linear equation, where does that line cross the x-axis? When we talk about the y-intercept, we're looking for where does that line cross the y-axis. Okay, so to put some official vocabulary to that, the x-intercept, it's the x-coordinate of a point where the graph crosses the x-axis. And one thing that every x-intercept will have in common is that it occurs when y is equal to 0. Because when we think about being on the x-axis, right, you can't go up or down for your y-coordinate. The y-coordinate has to stay 0. The y-intercept then is going to be the y-coordinate of a point where the graph crosses the y-axis. And every y-intercept will always occur when x is equal to 0. And again, that makes sense because to be on the y-axis, x has to be 0. You can't move left or right from the origin. You can only go up or down the y-axis. So x would have to be 0. So here's a graph with a picture of both an x and a y-intercept. And so the one down here, when we find our x-axis, so horizontally, where the blue line is crossing it, is right here at 3, 0. So we would say 3 is the x-intercept. But again, notice how the y-coordinate here is 0. So it's 3, 0. Okay, and then for the y-intercept, that's up here because we're looking for where does it cross the y-axis. So this point is 0, 6. So our x-coordinate is 0 and our y-coordinate is 6. Okay, so basically an easy way that you can remember this is that whatever intercept you're looking for, the opposite variable has to be 0. So if I want the y-intercept, x has to be 0. If I want the x-intercept, then y has to be 0. So it's like the opposite variable has to be 0. Okay, so let's take a look at a couple of more graphs and see if we can find and identify where those intercepts are. So for this first graph, I want both the x and the y-intercept. So first thing I'll do is I'll look at my x-axis, I'll look at the path of that line, and I see the line cross the x-axis right here. Now to give that point coordinates, I'm going to count over from the origin. This is 1, 2, 3, 4. And so my x-coordinate is 4 and my y-coordinate is 0 because I moved 4 to the left, or I'm sorry, 4 to the right, but I didn't move up or down at all. So 4, 0. All right, my y-intercept then is going to be right here on the y-axis. And when I'm looking at that point to find the coordinates, I start at the origin, I go left or right 0. So my x-coordinate will be 0, and then I'm moving up 2. So that's 0, 2. Okay, so again, remember when we're talking about each intercept, find where it's crossing that axis, and the opposite variable will be 0. Okay, let's try another one. So here's another linear equation. Put on a graph, let's find our two intercepts. So if I look for my x-intercept first, here's my x-axis, so the line is crossing it right here. Okay, that point looks to be -4, 0. And then for my y-intercept, here's my y-axis, so it's crossing right here. And this point would be 0, -3. Okay, so here's one more. I'm going to let you guys try this one on your own. So pause the video, write down what you think are the x and the y intercepts, and then you can continue on. Okay, so not only do we want to be able to find the intercepts when we're seeing them on a graph, right? But we also want to be able to find the intercepts of just the equation without having to graph it. Okay, so we don't need to graph the equation after all. Instead, what we can do is we can plug in 0 for the opposite variable. Remember we said that every x-intercept will have a y-coordinate of 0, and every y-intercept will have an x-coordinate of 0. So we can do this algebraically. Okay, so if I want my x-intercept, then I'm going to take my equation, 3x minus 4y is equal to 12. I'm going to plug in 0 for y. And now what happens is this entire term sort of disappears, right? Because 4 times 0 is 0, and subtracting 0 doesn't change anything. So I can essentially eliminate this term, and I'm left with 3x is equal to 12. Well, if 3 times x has to equal 12, I can divide both sides by 3, and x is going to be equal to 4. So my x-intercept is at 4, and the coordinates for that point would be 4, 0, because the x value is 4, and the y value, remember again, we chose that to be 0. Okay, let's now look for our y-intercept. To get the y-intercept, we're going to substitute in 0 for x, and then we're going to solve for y. So we're taking the same equation, only this time I'm plugging in 0 for x instead of y. Now, just like in finding the x-intercept over here, when I plug in 0, this term disappears. So 3 times 0 is 0, that's gone. But now I have negative or minus 4y is equal to 12. Don't lose sight of that negative. It's going to be a very common mistake that people are going to make. So watch for it, right? We always look in front of the term to determine if it's positive or negative. Okay, so if negative 4y is equal to 12, then I can divide both sides by negative 4, and y is going to equal negative 3. And so this is my y coordinate. Remember, my x coordinate was 0, so the ordered pair is 0, negative 3. All right, so let's try one more of these. All right, so I want to find the x and y intercepts of the graph of negative 5x minus 2y is equal to 20. All right, so again, we don't have to graph it. We just need to be able to plug in 0. All right, so real quick, if I want to find the x-intercept, where am I plugging in 0? Okay, so hopefully you said that if I'm going to find the x-intercept, I'm plugging in 0 for y. So right here, I'm going to have negative 5x minus 2 times 0. This term disappears. So I've got negative 5x is equal to 20. I'm going to divide both sides by negative 5, and my x-intercept is going to equal negative 4. And so that ordered pair now is negative 4, 0. All right, and if I want to find my y-intercept, where am I plugging in 0? Okay, hopefully you said if we want to find the y-intercept, we're plugging in 0 for x. Remember, it's always the opposite variable. So negative 5 times 0, that's 0. And so when this term disappears, we still have minus 2y is equal to 20. I'm going to divide both sides by negative 2, and I'm going to get y is equal to negative 10. And so I now have the coordinates 0, negative 10, because remember, we always list x first, then y. Okay, so that's all the examples for today. Make sure that you take a minute here to reflect, so something that you learned or were reminded of, and then any questions that you have, be sure to write down at least one thing for each prompt, and we'll see you in class tomorrow. Thanks!